offered to share her experience with us on linking OSeMOSYS and FlexTool. Recording started just now, so I might as well just repeat it for the recording. We were going to have Naomi Tan with us from the Climate Compatible Growth Program to share her experience with linking OSeMOSYS and FlexTool. We've been having technical difficulties, so we are happy to have also Juha from VTT presenting exactly on the same topic, as he also has great experience in this. So Juha, thanks for joining, and go ahead.
All right, so I'm let me share my screen.
Maybe say a couple of words about yourself and
Sure.
the tools.
So I'm a principal scientist at VTT, Technical Research Center in Finland. I also happen to be the lead developer of IRENA FlexTool. So we've been doing it for IRENA, and now we have Naomi actually join me. Let's see. Well, I'm also coordinating the MOPO project that's developing the spine toolbox, among other things. It's a 4-year project now, has been running for a bit more than a year, and it's a continuation project. So spine toolbox was originally developed in spine project, and now we are continuing the work. We are building more data pipelines. We are enhancing things in the toolbox side. We are building SpineOps as well, which is an energy system model, and then we are running some case studies in Europe. But right, for this project, it's the spine toolbox part that is of interest. I'm approaching the joining of OSeMOSYS and FlexTool from the perspective that I'm not just trying to put OSeMOSYS and FlexTool together, or we are not trying to. We are trying to make a common data format that helps us to make different models to communicate. I mean, if you would try to make all of these models communicate one by one, you will have a number of models to the exponent of something of different connections, and that would be a lot of connections after you have more and more models. So we are trying to work it through a common data format that we are also building in the MOPO project. That is actually quite far, and we have started the integration work for some of these models. Namely, out of this list, OSeMOSYS, FlexTool, PIPSA, SpineOps, we are putting there that can do both ways directions with the common data format. And of course, in order to make the OSeMOSYS and FlexTool link, I am using this same system. So another point about this system is that we are also building these data pipelines that will write to this data format. The same data format I'm trying to use to connect to different modeling tools will also have data pipelines that can provide input data, so you can build models using the model building system that we are making. We are trying to get the data at the highest possible resolution, open data, and then have a system where the user can define the target resolution, and then the build system will make you a model instance in that resolution. Another aspect of this is that we are making something we call an open certification process. So we have tests where you can try out whether your model is doing something correctly. So testing small things like a power plant startup or a transmission between 3 nodes, or any kind of a thing one might need in energy system, power system modeling, and we will try to have tests for all of these aspects, and then you can run your model against the tests and see whether you're getting the correct results. We try to keep the test so small that we actually know what is the right result, and that hopefully helps to increase trust in open source models if we get this effort not just based on us but based on a wider open source energy system modeling community. So behind all of this is a common data model that actually can serve all kinds of modeling needs. That's very generic. It doesn't need to be energy system modeling, but this is kind of in the background, and there are things like entity classes, attributes for the entity classes. You have entities and parameters and values and scenarios and alternative values for and metadata and so forth. And on top of this data model, there's a specification for this data model. We then have this energy system specific specification, where we then start using the language of energy systems like nodes and units and transfer links and such things. Then you of course will have a model instance that has the actual data, like these are more the data level stuff, and these are structure level things, these entity classes and attributes. So we are making this specification to facilitate the data transfers, and then we have an implementation of this in Spine Toolbox. But I'm trying to say that this is just an implementation. Someone else can make another implementation following the specifications. Doesn't need to be Spine Toolbox. Yeah. So the bit more about the data model. It's kind of based on what we did in the Spine project. We have been a little bit streamlining that since, and now it's following quite closely something called an entity attribute value with classes and relationships data model. But there are some additions there to cover things we typically need in modeling. So there's an entity class like a unit, and then there are entities like coal plants, and there are attributes to these entity classes like availability, and then you have value, that's a value for a particular attribute of particular entity, like 95% availability for a coal plant. These values can be constants, time series, time patterns, or more complicated data structures like maps, so multidimensional structures. And then also, whenever you have a value for something, you can have alternative values for the same thing. Like you could have an alternative for rusty plants that has a 85% availability instead of the 95% availability. And this structure of alternatives allows then to create scenarios in the database. And once you have scenarios, you can utilize that to run your workflows, which we will get to later. Okay, and then this is not just kind of a one-dimensional data. The data can be, the entities can be multidimensional. So you would have another class like node, and then in order to present information about connections between things, you can have multidimensional entity classes like a unit to a node, and then have an entity that is connects the coal plant to the west node, for instance. And then this is basically a graph like data structure, and this is from the Spine Toolbox that can then show you the structure of your data also graphically. All right, that was kind of a background part for the connecting OSeMOSYS and FlexTool using these things we've been building for several years now. And then this is a snapshot from Spine Toolbox workflow that I started filling up. It's a little bit complicated, so I'll try to go it through slowly, and it's maybe a little bit more complicated than it would need to be for just connecting OSeMOSYS and FlexTool. But as I was trying to explain, I'm trying to achieve something a bit more than that, and therefore there is some trips on the road. Let's see how it goes. So first, for OSeMOSYS, there is a OSeMOSYS model file. So this is the actual code that is the model itself. Then there is a data file.